All right, so let's take a moment to review the derivative rules for the natural log function. So the natural log of x, its derivative is 1 over x. And the derivative of the natural log of something else, so something more complicated, would still follow the same derivative rules, that's 1 over u. But then remember, the chain rule comes along and says we have to multiply by the derivative of whatever u is, the derivative of the inside. If we change to a log of any base, this formula gets a little bit more complicated. It's still kind of the same as a regular logarithm, but then we also multiply by 1 over the log of the base, natural log of the base, and then this one stays basically the same, but then we just multiply by the derivative of the inside. So that's just a rule. So every time we learn a new function, the chain rule, anytime we plug in something more complicated, the chain rule prevails. We follow the same original derivative rule, we just multiply by the derivative of the inside. So let's use the natural log function within others just to get some more practice with derivatives. So here what you notice is that we're going to need the product rule. And that's because we're multiplying x cubed times the natural log of x. So remember the way the product rule works, if you have u times v to start with, the derivative is, well, the derivative of the first part times the second, plus the first times the derivative of the second. So the long and short of it is we need to find the derivative of each piece. So the derivative of x to the third is 3x squared, and the derivative of natural log of x is 1 over x. So then that means that the derivative, I'm coming down here now, is equal to, well, let's see what we have here. So it's the derivative of the first times the second plus the first times the derivative of the second. And as always, we should clean things up if possible. Now here, I can rewrite that without parentheses. And now x cubed times 1 over x, rules of exponents tell me that that's just x squared. And that's pretty much as far as we can go with this. So that is our final answer. You may be tempted to factor out an x squared. You are more than welcome to do that. It's not going to get us anywhere right now until we actually start using derivatives. So another example is this one here where we have the natural log of a quantity. So this is one where we should think of it as y equals natural log of something, and we just use the letter u to represent that something because it's just a different letter than everything else that we use. So that means that the derivative is, well, the derivative of natural log of something is 1 over the something times the derivative of the something. Well, the derivative of x to the third plus 4x plus 2 is 3x squared plus 4 plus 0. And then we should always write it in a more condensed form if we can. Remember that that's really over 1. So that means we can write this as a single fraction and make it look really nice. So there's our derivative. So from here, anytime you find a derivative, just to remind you, remember derivative was just a way to find instantaneous rate of change, slope of the tangent line. So now we just have rules to be able to find this rather than having to go through that limit process. So the same thing that derivative has always told us, it'll tell us now. So hopefully this helps with the derivative of the natural logs and the logs. Actually, we'll do another one. What about y equals log? Not that we use regular log a lot. Log base 10 of, how about 3x plus 4? So remembering that the base is really 10, I am just going to write that in there even though we don't normally. The derivative, looking back at the formula, so log base a of x has derivative 1 over x times 1 over natural log a, the base. So that means that the derivative here is going to be, well, 1 over the thing times 1 over the natural log of the base, which is 10. So this 10 tells me that this term is going to be there. But then the chain rule prevails, so I now have to look at this. And I have to multiply by the derivative of 3x plus 4. which we know is just 3. So I'm going to write this out once more. And the only way we can really write this as, any more simplified is if we just write it all as one fraction. And there's your final answer in most simplest form. So hopefully that helps to solidify our knowledge of natural logs and the derivatives. Hope you found this video helpful, and thank you for watching.